So this is a question that we have today. If n is a positive integer and 2 raised to n plus 2 raised to n plus 1 equals p, then what is the value of 2 raised to n plus 2 in terms of p? This is a typical test question wherein students get a bit floundered in terms of what to do. Let's have a look at addressing this question in two methods. Let's first look at the conceptual way of solving this question. It goes as follows. We know that 2 raised to n plus 2 raised to n plus 1 is p. This is given to us in the question. The question asked is what is 2 raised to n plus 2 in terms of p. So obviously what we need to do is find a relation between n and p and try to sort out the question. Let's have a look. By the rules of exponents, you can take a 2 raised to n common outside. That's 1 plus the rule of exponents states that a raised to m plus n is a raised to m times a raised to n. Since we have taken a 2 raised to n outside, we need to write 2 raised to 1 and this is p. The next step that follows is obviously see what is within the brackets. So we have 3 times 2 raised to n is p. Let's go back to the question though. The question asked is 2 raised to n plus 2 in terms of p. So going back to the same rule of exponents, 2 raised to n plus 2 is 2 raised to n times 2 raised to 2, which is 4 times 2 raised to n. But since we already know that 2 raised to n is p over 3 from the first statement, we substitute that as 4 times 2 raised to n, which is p over 3. And that's our solution to the answer for this question. This is the textbook way of doing it in terms of looking at the answer options, working it out properly and getting to the answer. However, from the test perspective, we may not have enough time to solve all questions, and it is recommended to use strategies from the test perspective. Let's have a look at what strategy we can use here. The strategy that we can use here is called plug-in, wherein we substitute particular values of n and p and back solve from the options to get to the answer. Let's have a look. We can assume any convenient value for n that we wish to. So let's assume for a start an easy value like n is 2. Plug it back into the question and we have a 2 raised to 2 plus a 2 raised to 2 plus 1, which is 2 raised to 3, which is 4 plus 8, and that gives us 12. So according to our assumption, n was 2, and when n was 2, the answer to the question was 12. What we now need to do is go back to the question and see which of the options match in terms of the answer options. Let's plug back the same n equals 2 onto the question. So we need to get 2 raised to 2 plus 2 in terms of p, correct? Now 2 raised to 2 plus 2 is 2 raised to 4, which is 16. So we need to see which of these options is going to yield 12 as our answer, given that we substitute 16. Let's have a look. Option A suggests that it should be p minus 1, but p was 12, which gives us 11. That is wrong because we need 16. Let's go to the second option. It says p minus 1 over 2. That's clearly incorrect because that's going to give us 11 over 2. Let's go to option C, which gives us 2 times p, which is 2 times 12, which is 24. That's also incorrect. Remember, we need to get 16. Let's have a look at option D though, and that gives us 4 times p, which is 12 over 3, and this gives us 16. So there is a very good chance that this could be our answer. However, we need to ensure that we check for all the options before we get to the answer. Let's make a quick check for p plus 1 over 2. That gives us 12 plus 1 over 2, which is 13 over 2, which is not the answer. So since we have only one option that matches with the entire solution set, the correct answer to this question in the same way is option D, which is 4 times p over 3. Right, let's have a look at this question. They are asking us to find the 30th term of the sequence that's shown on the board. So the sequence goes, the first term is 4, the second term is 10, the third term is 18, and so on. At first glance, all of us can probably look at an easy sequence that is following, wherein you see that the difference of the first two terms is 6, the next two terms is 8, the next two terms is 10, and so on. Quite obviously, if we proceed in the same direction, we would get to the answer. It might take some time though, because the question asked is the 30th term, so we could, by manually writing it down, get to the answer. The second method to do this question is to obviously look at a particular formula that some of us might be familiar with, which belongs to the topic of arithmetic progression, wherein there is a constant difference between the difference of the terms itself. That's the second way of looking at it. But our approach to this question would be something very unique and something very, very easy to understand. Let's focus on this. Let's look at it a little in an out-of-the-box way. Since this is the first term, the answer is 4. What's the first thing that comes to my mind if I need to relate 1 and 4 in terms of multiplication? Probably a 1 into 4. That's the first thing that comes to our mind. Okay, moving ahead. I need to relate the second term to 10. So I need to relate the number 2 to 10. Probably 2 times 5 comes to our mind. Moving ahead, just to check if we are on the right path, I need to relate the third term, which is the number 3, to the number 18. And the first relation that comes to our mind is 3 times 6. By now we are able to observe that there might be a certain pattern. So if we are sharp enough from the exam perspective, then we can quite clearly see that this number is going to be 4 times 7, while this number is going to be 5 times 8, and so on. So now we are sure that there is a particular pattern for the sequence of numbers shown. So if they had given you any number here, we can get to the answer almost immediately. Going back to the question, 1 times 4, 2 times 5, 3 times 6, etc. So if it's the first term, the answer is 1 times 3 more than 1, which is 4. If it's the second term, the answer is 2 times 3 more than 2, which is 5. So if it's any term, if it's the fourth term, the answer is 4 times 7, which is nothing but 3 more than 4. Similarly, the fifth term, the answer is 5 times 8. 8 is nothing but 3 more than 5. Hence, the answer to our question is 30 times something which is 3 more than 30, which is 33. And the answer is 990, which would give us this option. In the exact same way, had they asked you the 300th term of the sequence, there's absolutely no reason to worry. The answer would turn out to be 300 times 303. So you just have to invest a few seconds in computing this and you get to your answer. This shows us quite clearly a much better approach to this question. Right, let's have a look at this question. This is one of those questions that's quite difficult to answer on the test. So for those students who are looking to really score or ace the test, this is one of those questions that really pushes you up to the next level. Let's have a look. They are telling us that the value of n is 8 raised to 7 minus 7 raised to 7, the whole thing over 8 raised to 6 plus 7 raised to 6. And they are asking us the value of n. Be careful on the test. They don't expect you to compute the exact value. What they want you to find out is in which of these ranges does m lie. Quite obviously, this is one of those questions wherein if you're going to sit and manually count all this, it doesn't make too much sense. Let's see if we have a shortcut for this. There is something called the pattern method which we can follow from the test perspective for this question. Let's have a look. Let's take smaller numbers that look like this but are exactly not this, and let's see if we are able to consistently get somewhere in terms of our answer options. Let's look at smaller numbers. There is an 8, there's a 7. Here it says 7, 7, and this is one lesser, which is 6, 6. I'm going to follow the same pattern but with different numbers just to observe what the pattern is. Let's have a look. What I've written here represents the exact same model but in a smaller thing. So let's see what the value of this is. We know that 4 raised to 3 is 64. while 3 raised to 3 is 27. So we have 64 minus 27 over 16 plus 9, which is 25. This gives us 37 over 25, and quite clearly the value is more than 1. Okay, so we've understood that for this particular set of numbers, the answer is greater than 1. However, this need not be true always. So let us check out a few more values. Let's go to the next level and see whether it still holds good. Let's look at a 5 raised to 4 minus a 4 raised to 4 over a 5 cubed plus a 4 cubed. So a 5 raised to 4 is 625. 4 raised to 4 is 256. 5 cubed is 125, while 4 cubed is 64. As you can see, you need not compute this too much. This value is going to be closer to 400, while this value is going to be a little less than 200. Quite clearly, the value is more than 1. If you want to take even more smaller numbers and check out, just to make sure if this computation looks a little difficult, take even more smaller numbers and let's see. 3 square minus 2 square by 3 raised to 1 plus 2 raised to 1. This value itself gave us 9 minus 4 over 5, which is 1. So as you can see, for smaller values it was 1, but as we proceeded to bigger values, the answer became more and more greater than 1. Hence the final answer by consistency is going to be m raised to m greater than 1. Right. So here we have a typical geometry question, typical test question, wherein they want us to relate the value of x, a, b, c, d. Always remember, whenever they give you the question in terms of variables, the best strategy for such a question would be to plug in. If you look at the answer options, there is a possibility that more than one answer could be right in terms of choosing one value. However, if you choose another set of values, you will realize that the answer has to be only one of the options. Let's have a look how we can solve this question in less than 20 seconds on the test. We want to relate x, a, b, c and d. We look at the options and the options don't really give us a bit of clue in terms of how do we go about doing it. Plug in any value that you want in terms of x. So let me choose the value of x to be, for example, 100 degrees. If x is 100 degrees, if everyone can observe, this is a straight line, which would mean that this would be 80 degrees because this forms a linear pair. Focus your eyes on this triangle that I am showing you here. If this angle is 80, these two angles put together have to measure up to 100 degrees. The reason being, the angles in a triangle add up to 180. By the exact same logic on the other side, because of symmetry, this angle is going to be 80, which means these two angles, that is C and D, added up give me another 100 as well. So the final answer to the question is 200 degrees because they want us to relate x in terms of a, b, c, d. If x is 100, the final answer is 200. So let's see, after we plug in, what happens. Here it's 100, here it's 100 plus 90, that's 190, while here it is 2 times 100, 200. However, let's have a look at the other ones as well. 100 plus 180 gives us 280 and 100 minus 90 gives us 10. So quite obviously, the answer can be gotten within 10 to 15 seconds by using the plug-in strategy. So in order to ace your test, obviously you need to work hard, but you also need to work smart. So as far as your test is concerned, always remember not every question is going to be unsolvable, even though it may appear to be so. What you need to do is use a little bit of your strategies, use a little bit of common sense and go with the options in terms of cracking the question itself. If you can do that, that would be a huge step in terms of you acing the test. To know more, follow us on more such videos. Thank you.